Hello, and thank you for registering to attend How to Fit Check and Install MLI in Quarantine. My name is Casey Kelby, and I do business development and thermal engineering here at Aerothreads. And today we have an exciting program for you. So we're going to start off with a little panelist introduction. So here on the call with us, we have Art Mallett, the Vice President of Global Aerospace at Dunmore Aerospace. Unfortunately, Orbital Composites couldn't be here with us today in person, but I prepared a few slides on their behalf so you can learn a little bit more about them. And then a little background about Aerothreads and what we do. Also in the room with me here today is Ariel Pond, one of my colleagues here at Aerothreads. She's a lead thermal blanket specialist and does all of the really cool and exciting blanket work, climbs on the hardware, does modifications and designs. So if you've worked with Aerothreads in the past, you're probably very familiar with Ariel, but she'll be leading us through our fit check and installation demo today, as well as answering some questions. So we are also going, after our demo, we're going to have a brief period for Q&A. So if you have any questions, feel free to drop them in the chat box on the live stream. I'll definitely be monitoring those as we go along. If they're related to the demo as we do it, we'll go ahead and answer those as they pop up. And then if there are more general questions about Dunmore, Orbital Composites, or Aerothreads and our capabilities, we're going to save those to the end. And I also have some prepared questions for the panel today. And that is that for right now. Let's see. Cool. So that's our agenda. And also, if you received a demo kit, all of the materials in the demo kit were donated by Dunmore Aerospace, and the 3D printed block you have was provided by Orbital Composites. So that's kind of where our panel stems from today. So we're going to start off at the top with our unfortunately absent members, Orbital Composites.
Hello.
Oh, he is here. Cole, do you want to talk a little bit about your organization?
Sure. Yes, I'm Cole Nielsen. I started Orbital Composites a few years ago, about 5 or 6 years ago, and the goal was to be able to produce a 3D printer that could make a satellite with a very small number of parts. So then we decided to start building tools for carbon fiber 3D printing and thermoplastic and thermosets and all kinds of different composites. And so now we have a bunch of robots to do this. So that's kind of our background in a second.
Sweet, thanks, Cole.
Yep.
And then Art.
Yeah, thanks, Casey. So pleased to be with everybody today. My name is Art Mallett. As Casey said, I am the Vice President for Global Aerospace at Dunmore. And we have really the pleasure of being the premier material supplier, not only for what you're going to be working with today, but for all of the material or all of the programs that are currently ongoing with NASA and commercial space and European space and lots of other programs around the world. So it's a great position for us to be in, celebrating over 35 years of participation in the space and aircraft business. So we've got a good team. We are headquartered in Bristol, Pennsylvania, just outside of Philadelphia. And we really focus in 3 particular areas for the aerospace side. We have MLI materials for spacecraft. We do interior and thermal acoustic insulation materials for aircraft. And we do lightweight structures for airships and aerostats and other inflatable type materials. So those are the core products that we are producing every day and sending out to our customers like Aerothreads to make into something exciting and applicable to your projects. We also do some work on the cryogenic side. So we've got some materials that are able to insulate products that are meant to be, extremely cold, whether those are LNG tanks or other cryogenic liquid tanks. But that's another unique market that we participate in globally. We've got some great experience with lots of different flexible films and fabrics and materials and adhesives and coatings. So the idea on our side is, bring us your challenges, bring us the discussions about materials that could potentially be, useful or new or novel for your projects. As we continue to explore the solar system and look at different places that we've not really been to, like the Europa project or someplace else. We're willing to, look at things that are different that haven't been used for the past 35 years. So definitely some interesting opportunities going on there. We are supporting the constellation companies. So a little bit of a different concept than building a big geo satellite or a interplanetary spacecraft. We are now looking at how do we support somebody who's going to build the same thing hundreds or thousands of times. So that certainly expands out to, again, our partners like Aerothreads and the fabrication side for something that's a duplicate part over and over again. At the end of the day, we have a great team. Again, I included a slide in here. I'm assuming Casey will share the presentation with the entire group of participants. But anything you need, you can reach out to any one of our team, and would be pleased to talk to you, pleased to help you with your material selection. So good luck today. Enjoy it. Let's have some fun.
Thanks, Art. So I wanted to give, for those of you that didn't know Aerothreads before this stream or box was delivered to your house, I wanted to go through what we are and what we do. So Aerothreads was founded in 2014 by our CEO, Alex Bogunovich. And in that regard, we are a women-owned small business. We recently relocated to Riverdale, Maryland, and we'll talk more about that on the next slide. But we're about a mile down the road from our old location in College Park, if you're familiar with that location. And we specialize largely in multi-layer installation for spacecraft. So whether it's consultation on a process, design of MLI, up to fabrication, installation, and additional critical support services, we have you covered, pun intended. And then we also support various soft good projects. So these can be things like contamination covers, clean tents, basically whatever clean room or technical challenge that you may face. And then we also work on some key special projects. So if you came to IAC in 2019, you may have received that gray bag as your welcome bag. We designed it with the support of Dunmore Materials to bring that bag to fruition. And then also when COVID struck, we started making some cotton masks, which are still available for purchase, and you can definitely email us if you're interested in finding out more info. Also on this slide, the top right, you can see Ariel and Alex working at, I believe, a Goddard clean room, supporting a customer there. And then on the bottom right is a picture of our team at IAC 2019. So as you can see, we're a small group, largely made up of classically trained artists. So Ariel and a lot of our coworkers have a background in fiber art, costume and fashion design, puppetry, sculpture. There's a lot of, if you can cover a person, you can cover a spacecraft. So a lot of crossover of those skills and that kind of engineering meets art mindset, which is pretty interesting. It makes us stand out among others that do similar activities. And again, I want to touch on our new facility. So Ariel and I are currently sitting in our 10,000 square foot new facility in Riverdale, Maryland, excuse me. What makes this really cool is we have a dedicated clean area where blankets are designed and fabricated and prepared for shipping. This includes a ground wire fabrication station and also a precision cleaning area, which is really neat. So over here on the right, you can see some of our precision cleaning and our ground wire station, and a little demo kit that may look really familiar to you if you received one in the mail. So if you're joining us, if you received a package in the mail from me, you are more than welcome to play along, as they would say. So in your box, you should have gotten a multi-layer insulation blanket that is this orange Kapton color. You would have received a template for that blanket, a 3D printed block provided by Orbital Composites, some MLI edge tape. It might be rolled up inside the demo block, so make sure that you check in there if you haven't found the edge tape yet, and also a notepad if you want to take notes. And then again, just to reiterate, all the materials were donated by Dunmore Aerospace to help us with this endeavor, and the block was donated by Orbital Composites, which is why both of them are on our panel today. In order to prepare for this demo, we highly recommend that you make room around your computer and work area to have space to work on these things. Obviously, when the template and the blanket are flattened out, they're not super big, but they do take up a little bit of room. We recommend you have really sharp scissors, a ruler or straight edge handy, and a Sharpie or some other kind of permanent ink marker. So if you would like to go along with us, I'm also going to be doing this demo, which will give Ariel some good timing and also some interesting work on my behalf, because I don't often make MLI blankets, and I don't think I've made one in 2 years, so this will be a fun adventure for Ariel. And also, if you hear me like deep, angry sighing, you know why, but it should be a lot of fun. So I'm gonna get into this demo portion. And this will also be available, I believe Parker said that this is going to be made available on the website next week, perhaps. So if you lose track or we're going too quickly for you, feel free to either leave us a note in the chat and say like, hey, slow down, or drop any questions in the chat. I'll be monitoring that. And if you do lose track, feel free to come back to this next week and try your hand at it again. I think it might also be fun to do with like adult kids that you may have, or spouses, or relatives, whoever. This might be a fun activity for them too, at least to learn more about thermal engineering and MLI. So, and I wanted to preface Ariel's portion of the program with a little bit of information. So why virtual? Why are we supporting both virtual fit check and install? This really comes down to the fact that, I mean, we're in a pandemic, so travel restrictions have been significant. We often can't come to our customer sites and support these. We've also, in the course of time, discovered that some of our, newer folks on the block, their budgets are more limited. They have a tighter timeline, and the complexity of their MLI is relatively low. So knowing that that the complexity is lower and that they probably have the skills, or at least can be taught additional skills to kind of make an install or a fit check successful, even virtually. And just to reiterate, since I know fit check and installation might be jargony if you've never dealt with MLI before, fit check uses the patterns or templates onto the flight hardware to tailor the MLI. This includes modifications to the template to inform the final flight MLI. And then installation is that final integration of MLI onto the hardware. Often this includes fastener attachment, seam taping, and ground wire routing. So you'll notice when we go through installation here, there is no fastener accommodations, there's no ground wires present on your sample. That was just for speed of production. But in a real MLI situation, you'd have to deal with those things additionally. So just kind of wanted to preface that. And let me get situated while Ariel does this.
All right. Hi, everybody. As Casey said before, my name is Ariel, and I'm a thermal blanket specialist here at Aerothreads. I have the lucky job today of kind of walking you guys through what I do on a day-to-day basis. So to start off with, just as Casey said before, I was going to give you guys a little bit of a preface of the anatomy of MLI and templates, because as me and Casey are people that work with these things every day, it's very easy for us to just start talking about these things, but I want to give you guys a little bit of a peek inside to what everything is. So we have our 3D printed image here, or 3D printed hardware here, which I'm just going to refer to here on as the hardware. We have our MLI template with its label, so that way you know which way is facing out. We'll get into that a little more later. We also have examples on both of the MLI and the template on what a flange or an overlap is, and that's in a way so that we don't have any butt seams in between any of our blankets. We want to make sure thermally everything's nice and covered and there's no chance of leakage. We also have pointed out here what a stress relief punch is, and we can see that even better on the next slide that I'm going to show you guys. But basically, it's a way that helps fabrication, but also helps installation, so that we have a very small punch at the end of any slit or any internal corner, so that the film will not rip. And it's also a good place for us to make sure that our cut line stops and that our tape ends. And then lastly, this blanket is a Kapton outer facing blanket, so we'll just pointing that out to you as well. Continued with the anatomy of our MLI this is the inner layer of our MLI. It's VDA out for our inner layer. You can also tell that it's our inner layer because we have our MLI label here made out of Kapton and Sharpie that's taped over in a little Kapton sandwich. We can see our edge taping as we go around. It's the Kapton edge taping, and that's to match our outer layer of film, and that's pretty typical on any blanket that you'll see. Again, we can see a little bit clearer of an image of our stress relief punch as well as our stress relief tape that helps protect those really critical parts of the blanket. And again, another image of where flanges or overlaps might live. So guys, it is time to begin our fit check. Casey, are you ready?
Ready.
Awesome. So one thing is that this blanket and this hardware are slightly different. Our hardware had changed since we first templated and fabricated our blanket. So we're going to have to go ahead and do a template fit check and MLI modification in order to install the MLI on our hardware. So we're going to start by orienting the template to the hardware as shown in this photograph. Basically, what I'm going to call the back side of the hardware is the side of the cube that has the longest side, and that part of the hardware lines up with this panel in the hardware that the arrow is pointing to that has the cap kind of top coming off of it. So we're going to begin to install the template on the hardware like that, and you can use tabs of tape. Usually in the clean room, we would go ahead and use Kapton tape, but for the purposes of everyone being at home, of course, we can go ahead and use our Scotch tape. And as you guys will see as we're going along, this fit check is going to get a little iterative and repetitive. We have to usually put the template on the hardware kind of multiple times and take it off to modify so that after, specific checks are done, we do our modification and then we install it back on the hardware to make sure our modifications are working correctly. So it looks like Casey has it all set up, so we'll move on. Hopefully you guys are in the same spot. Whoa. All right. So first off, we need to modify the height of the three sides. So we're going to start by marking a start and stop for each line with, in our case, we're going to use a red Sharpie, but as Casey said before, whatever permanent marker you might have. And for easy access, I've circled those in the PowerPoint presentation here.
I made a mistake. I taped down the side flanges.
Oh, no. That's okay.
Making this really hard.
Yeah, so what Casey had here was she had kind of taped the top of the box down And the reason I did not ask her to do that or ask you guys to do that originally was because that top flange can kind of get in the way of where you're trying to mark your modifications for the sides. So just a little tidbit tip there. So next, what we're going to do is we're going to remove our template from the hardware in order to finish marking our lines. And the reason we're going to do that is because a lot of the time it's easier to go ahead and make those revisions on a flat surface instead of doing it on the hardware. Also, there are times where hardware can be very ESD sensitive, and we don't want to risk taking any kind of plastic tools like a ruler or, you know, anything that can kind of hold a charge. So it's just a little safer to kind of be a little more iterative in your process, putting your template on, taking it off, and making modifications. Next, what we're going to do is we are going to use a ruler to connect all of our lines.
Oh, and those lines. I didn't mark over here either.
It's okay. So if you didn't mark your overlapped flange on the side, what you can do is just kind of mark a line that is coming straight out from that fold line there. So if you draw a line that's completely perpendicular to that fold line, then you will have a successful modification.
Gotta follow instructions.
That's okay. We can always usually have a workaround.
True.
All right. So here, all of our lines have been connected, and so now you're ready to go ahead and cut your template at the red line. Typically how we do it is we cut on the very outside of our red line so that we still have the red line marked on our template, but it's cut right up to it so that it's not going to affect when we use our template as a guide to cut our MLI.
Oh, that's a good question. EJ sent a question. He asked, what are the templates made of?
The templates, they are made of a, I believe, 4.4 mil Mylar that's coated with an ESD coating, and it's, I think it's, the trademark name is Melanex.
Mm-hmm.
And yeah, that's basically what it is. It's a 4 to 5 mil Mylar that is ESD safe for hardware applications. And I think there's other versions that have different levels of clarity to them, if I'm remembering correctly, Casey. But we definitely like to get the kind that is ultra clear or super clear.
Yeah.
It makes templating on the hardware so much easier when you can see what you're actually templating. All right. So next here, we're going to go ahead and reinstall our modified template back onto the hardware so we can continue with our fit check. And we want to also make sure as we're putting this on that our previous modifications have been successful and they're working in the way that we intended them to.
Wow.
Looks good, Casey.
Champ.
Looks real good.
Who knew?
I might get to retire.
Don't quit on me yet. Wow.
Awesome. Looks great. So now that we have modified the height of our sides, we are ready to go ahead and bring down that top cap bit. And typically, this cap would be installed first with so that all of the flanges that we have would live under the main body of the MLI. However, for our template fit check purposes, we are going to go ahead and have the flanges on the outside so that we can mark them if we need to modify them for any reason. Aha. Now that we're going around to the sides of the cap, we can see that the cap flange is sticking out a little bit over the corner of the box. So we're going to need to modify that, because if we were to install the blanket in that kind of way, then there would be a lot of crunching on the edge of the blanket, and also that corner of the blanket then wouldn't fit exactly as it intended to, because there would be all that extra bulk there. So we're going to go ahead again and mark where that flange intersects with the MLI fold, and those areas are circled in red here on the PowerPoint. And we're going to want to make sure we do that on both sides. Oh, Casey, don't remove anything yet.
Oh, no.
Be careful. Hold on.
I jumped ahead. Mistakes.
So our engineer, she just called, and she said, hey, there's going to be a harness that's installed at the top hole of the slanted part of the box. And this harness, it's going to be installed and mated before the MLI is installed. So that way we're going to have to put a 1 inch by 1 inch X-cut and a slit to get around the harnessing when we install the blanket. So what we're going to have to do now is mark our circle location, which is also our harness location, just with the dashed red line. We don't have to get too fancy, too crazy, just to know generally where it is. Okay, so now we can go ahead and remove the template from the hardware, as we've kind of looked over the whole thing, you know, and that was what we are now assuming to be our last modification.
It is nice that you can pick it up and move it everywhere.
That is very nice. Typically, that's not the case. Typically, you can't just pick up, you know, an instrument or a spacecraft. They usually frown upon that, yeah. Or it's just too big.
Too big. Okay, look at it.
So we're gonna deinstall our template and lie it flat like we did before, and we're gonna go ahead and connect our red marks on those flanges, on those flanges that are coming from the cap. We're gonna connect the red marks to the stress relief hole, and then we can cut away that little area.
That's a good question. So AJ sent a question, says, I'm curious, is it intentional that the template material is much less flexible than the MLI blanket itself?
I think for the MLI material, it changes so much based on what the layup of the blanket is that I don't think it would be kind of very challenging to have a template material that could replicate the thickness and rigidity of every different type of MLI, or in some cases SLI, that you were to create. So I think our Melinex, although more rigid than a blanket, is kind of a good kind of holding place for the thickness of MLI. And what we really like about it is that because it's so rigid, it does very well hold any kind of folds. And, you know, when we get more into learning about the MLI process, pretty much all of what fabrication surrounds around is how to form and fold the MLI so that it meets the shape that it needs to. So, but it does become interesting. Sometimes our templates become much more of a shape than our MLI if we're using maybe only inner layers, you know, only 1/4 mil and netting on something. Our blankets are a little more floppy than our templates, but then if we're doing a layup with Kevlar in it, or maybe a couple layers of Kevlar, our blanket's going to be much more rigid than the template was. So that's an interesting question.
For sure.
So next. All right, guys, so if you're anything like me in school, you were a teacher's pet. So we have a little bit of extra credit here. This is something you don't have to do, but it definitely is helpful for the fit of the MLI at installation. And what we're doing is we're kind of creating a beveled edge on these flanges that we just modified in order to reduce bulk. So we are going to mark a 1/4 inch up into the flange from the red mark that we had gotten from the template fit check. And then we will connect this new mark to the stress relief hole in order to create a little more of a beveled edge. So this way our edge is staying just a little bit more away from the corner of the MLI. And it doesn't seem like it would do a lot, but it actually does help the fit of the MLI quite a bit when you start to kind of cut back at these areas like that.
I'm going for it.
Yeah, go for it.
Oh no. The question machine has fallen asleep.
Oh no. And when we do this, we're going to do this on both sides of the flanges, and we will again cut on the red line.
Ooh, there's a lot of messages. Let's see. Oh, wow. Why do you use Kapton tape for the template? To be able to see it?
We use Kapton tape mainly because it's a pretty much it's used in all clean rooms. It's allowed in clean rooms. It's flight compatible, so it can be put onto the hardware, and it's usually not too much of an issue. Sometimes you'll have to deionize it before you put it onto the hardware, but also we don't have a instance where the adhesive kind of comes away from the film too easily. It's a pretty robust tape. So I'd say overall we can find it pretty much in every clean room, so it's pretty accessible. It's pretty much the only reason.
So Michael asked, did you say we should cut along the edges of our lines so the lines are still visible on the template after we cut?
Correct. Correct.
So don't cut off the lines. Michael,
Yeah.
I did that a second ago, but now I'm grateful for extra credit.
And the reason for that is just because when you go to put your template on the blanket, it makes it so much easier to see the edge of your template because, as we all know, the template is see-through. So it makes it much easier to identify where the template starts and the blanket begins. Mm-hmm. All right. So next here, we are going to do our little harness modification. We're going to go ahead and find the center point of our circle that we marked earlier.
Center point, she says.
Mm-hmm. All right. And then using that center point, we're going to create an X that is 1 inch by 1 inch, and it is centered on that center point of the hole that you just found. And with this, you can eyeball it. You know, that's usually pretty good. Some people, if you're like me, you like to really measure it out. That's for the...
That's a little oblique.
That's okay, you know. Well, you know, it'll pass. It'll survive.
Okay, cool.
Next. Okay. Then we're going to go ahead and draw a slit from the end of the X to the nearest stress relief hole. In this case, every stress relief hole is equidistant to the end of the X cut. So I wouldn't stress about it too much, but when we're templating, we either try to find a place that is the least distance because we don't want slits and holes all over our blankets, then they become Swiss cheese. Or we also will pick our slit locations based on accessibility, what's going to be easiest to close out, or if we have a possibility of flanges coming from other blankets that can cover over this slit, that's also helpful to keep in mind. All right. Next, we will go ahead, now that we've done all those modifications, we can go ahead and do our final fit check after all of our modifications that we've done. So we're going to fit our template back onto the hardware. At this point, we're going to go ahead and install the template in the same progression of how the MLI will be installed. And by that, I mean, first we'll go ahead and fit the cap on, and tape all the flanges down onto our hardware so that they live underneath the main body of the MLI blanket. And we're also going to want to check when we put that cap on that our harness location, our X-cut and our slit are in a location that we're happy with.
All the fish up, Stacey.
I know, it is a little crazy how many times it goes on and off, for sure.
In the order that we put it on the hardware.
Yeah,
Lid on first.
looking nice. Then we're going to begin to wrap the hardware with the sides of the template, and we're going to want to double check on our flange modification to make sure that we like where that ended up lying. It's not lying over the line for the folds in the template. It's just on the inside of the block. And we're going to, again, although we already did this, we'll just check again. We're going to verify the height of the sides from our first modification to make sure everything's lining up nicely. And guys, of course, it's me, so we have another extra credit moment where we have the overlap from the top cap and the overlap from the side body coming to each other. We see right there, once we finish installing the blanket, there's going to be 3 layers of blanket there. And that's kind of, it gets a little too bulky. And these layers of MLI, once, you know, typically they're about, I would say, 1/8 of an inch for a standard layup. Once you get to 1/8 of an inch, 1/8 of an inch, 1/8 of an inch, you know, you almost got 1/2 inch of blanket in that area. So you want to always be careful with that kind of stuff. So what we're going to do is we are going to go ahead and bevel these overlaps. We're going to go ahead and draw a diagonal line between the two on both sides and cut away at them so that we'll have removed 2 triangles of extra material. And usually, the way that I like to do this is I'll go ahead and mark my first diagonal line on one of the overlaps, go ahead and cut away at that line, and then you can then transfer that diagonal line to the other overlap. And for a small modification like this, I wouldn't worry about taking it on and off the hardware. It's something small that you don't need to affect the entire body of the MLI, and so I don't think there's any reason that you should have to remove it again unless for your project the requirements are that stringent on the hardware that you'd want to always take it off. So once you have that completed, it'll have a very tailored look to it, which is what we like here at Aerothreads. And once you have that modification done, you can finish wrapping the sides of the template around, and that completes your template fit check.
Sweet.
Great job. It looks good.
Wow.
So now that you've done all that work, taking it off, putting it on, taking it off, put it back on again, we're going to take it off one more time. We're going to remove it from the hardware so that we can use this as our tool to modify our blanket.
This is going to be noisy. Apologies. Sorry, guys. Okay, there we go. You have my blanket?
Oh, yeah. So now we bring the star of the show, our blanket. We're going to face it so that the outer layer, the Kapton layer of the blanket is against our table and our workspace, and the VDA side is facing us. We always fabricate our blankets with the inner layer facing us, and in that regards, we are also going to be placing the template in a very specific way against the MLI so that we don't fabricate anything inside out and backwards. We want the outer layer of our template to be touching the inner layer of our MLI.
Okay, Michael says he's falling behind.
Sorry, Michael.
Let's see. Can you let us know what phase you're on and we can go back a couple slides? Guess I am better at this than previously thought.
Well, you've done it 2 years ago.
True, I did it so long ago. I'll give you a minute while I stick this thing down.
Yeah, during this step, you just really want to make sure you take care to line up your template in the way that your blanket was fabricated. So try to make sure anything that wasn't modified on your template lines up with the previous version of your blanket. So all of your stress relief holds, for example, should line up well.
Do you want to go back to the fit check picture, the final?
Sure.
Maybe this one? Go one more.
This one.
Oh, no, go, sorry, where the finished template.
Oh, when it's
flat.
flat, gotcha.
Yeah. Maybe this will be a good cheat sheet for them while I'm sticking this thing on. Trimming angles on the template. Oh, I guess that's these ones, this cut probably.
Oh, okay. Oh, I see.
Do you want to go back to that one?
Yeah.
He's looking for that extra credit.
That's why he's falling behind, he's doing all the extra credit.
Do blanket modifications get more challenging when you have blankets with more layers?
Absolutely. So I was working on a project that was so it used double netting and it had, I believe, 38 inner layers. So by the time you count up all the netting, you count your inner and outer layers, we were, I think, at over 100 layers. And this blanket, I think it was about 3/4 of an inch thick. So it was very challenging to modify, especially it needed modifications after it was installed because there were changes to the thermal design based on testing. So that became quite challenging to modify. So definitely, if I were to have a 5-layer blanket with inner layers of just perforated and embossed, no netting, that would be a breeze to fabricate versus a blanket that's really thick or a blanket that has MMOD or Kevlar layers.
Kevlar. See? Do you want to go back to the, he's got the bevel, wait, let me see.
Okay.
Looking at where we have 3 layers overlapping on the short side, you recommended beveling 2 of these layers so they don't overlap. Yep, so those are the, flanges?
Yeah, it's a flange from the top cap, the center flange there, and a flange from the main body sides. So that was the flange kind of if you're just looking at it all the way over to one side. But again, if that's something that you want to spend a little more time looking at, it's something you can always look back at later as well. What we're doing now will not affect if you can do that in the future.
Cool. Cool, I think that's it. Okay. We can go ahead.
Oh, right.
I'm almost all stuck down here.
Yeah, definitely. If you wanna do it right, it takes a little bit of time. And I don't know if I mentioned this before, but one good way to check if your template is oriented in the right way is if you can't read the label on your template, if everything looks backwards to you, then you're on the right track. That's how we always check and make sure. If you can read the template, that's a scary sign for us while we're fabricating.
For sure. Oh, this is an interesting question. How do you get rid of the small discs you punch out at the ends of the cuts in the MLI to avoid foil ripping? Oh, like for the stress relief punches.
Oh, where does those little pieces go?
Yeah, like the Chad.
So we have hollowed out punches that we use that are at very specific that you'll use a pick of some sort to clean them out.
Mm.
So it's all kind of self-contained.
Yeah. Yeah, you definitely, I know you mentioned the quarter mil inner layers here. The benefit of kind of punching and making sure that the edges are taped out is so that you're not ripping those inner layers. And
Absolutely.
it's one fell swoop punch, because you definitely don't want to do it halfway.
Absolutely.
Cool. Let's keep going.
All right. So next we're going to begin our modifications. We're going to modify our MLI one modification at a time. We're not going to go ahead and cut the whole thing up and hope it stays together. We're going to go ahead and cut our one side, and then after that we'll tape that one side and kind of continue that process all the way around our blanket and completing all of our modifications.
If you're getting resistance, you're cutting the template.
Yeah, do not cut the template, please, but if you do, just try to avoid it in the future. And in this, you can, use scissors, you can use a scalpel and a straight edge, but if you decide to use a scalpel, definitely be very careful.
That doesn't have netting.
No, that was a test blanket for Mass Prof.
Ah.
So once you have that cut, we're going to go ahead and edge tape our blanket. We're going to use our 1-inch wide tape that came in your demo kit. We're going to make sure that we have a 1/2 inch on either side. We want it to be a nice even application. I would suggest a length of 2 to 4 inches for your taping just to get comfortable. And make sure that you kind of pull your template out of the way while you're doing this, or else you're going to end up taping your template to your blanket and then you will cry. And we don't want any tears, guys.
No tears.
We just want happy blankets.
No tears in MLI.
The easiest way that we like to edge tape in this current orientation is to kind of go ahead and slide your tape kind of halfway underneath the MLI so that half of the tape adheres to the outer layer of the MLI and then the other half kind of pokes through. And then you're just going to take that other half that's poking through and fold it over onto the inner layer. And that's the reason too that we like to use scalpels to do this, because we can use our scalpel to kind of fish our tape underneath, pull our scalpel away, and then go ahead and fold our tape over. You can do it just, with your hands too, but for some reason the scalpel is just a nice tool to use. And we're just going to continue our edge tape all the way down the perimeter of our modification. We want to make sure that we use tape that overlaps at least a 1/2 inch onto the previous piece of tape. We don't want any kind of butt seams at all.
Here's a good question for you. How do you ensure that your MLI layers aren't shifting with respect to each other while you're working with it?
So that's a good point. So this blanket that you guys have right now is fabricated flat. And that was because some projects, it may be a test project, or as Casey said before, some projects don't have all the funding that it would like to have. So in order to kind of meet deadlines and to kind of meet budget restraints, sometimes we'll fabricate a blanket flat because it's a lot faster. Usually we would like to form all of our blankets, because then that way you don't have any of the, when all the blanket layers come together at a corner, you're not going to have bunching and crushing and therefore a reduced thermal performance. So when you're fabricating a traditional blanket, you do want the layers to shift, but you kind of want them all to shape together. And we use weights, we use forms in order to achieve that. All right.
Michael's caught up.
Okay, awesome. I'm so glad. And this slide is just an example of, at this first modification, you're gonna get to an internal corner here. And because we still wanna overlap our tape a ½ inch, it's just a little tutorial on what to do when you get to that internal corner. And what you'll do is you'll just simply slit the tape at that innermost point and then kind of treat both sides of the tape as their own pieces of tape, wrapping them around to the inner layer and continuing with your modification.
Extra credit moment again.
Again, yeah. You know me, guys, by this point. All right. Now we're fast friends, yeah. So we will continue on to our next modification on the other side of the blanket, and we're gonna do pretty much the same thing we just did on the other side. We're gonna go ahead, using a scissors or scalpel, go ahead and cut away at our modification. We want it to match the template exactly. You don't want it to have a little bit of extra pieces anywhere, because that will, again, influence the fit of your template, or influence the fit of your blanket on the hardware.
She's looking at me, man.
You're looking at me. It's okay.
It's hard being in the same room with you.
Oh, sorry. I'm sorry.
I'm kidding. You're very easygoing. You're not judging me too hard.
No, I try not to. You're doing a great job, Casey, and everyone at home, I'm sure you're also doing a great job. Hey, Casey, is there any way that they could share their photos of their finished modifications
sure.
with us?
If
That
you
would be
guys
awesome.
want to jump on social media, we're on Instagram, Facebook, LinkedIn, Twitter, all the things. All of them are at Aerothreads, Aerothreads. You can also mention Dunmore and Orbital Composites if you'd like, and you can post them, and I would just maybe either add us, like mention us in your post, or use hashtag Aerothreads, and then we can see it. That would be really cool if you don't mind sharing it.
Yeah, that would be awesome.
And if you had a friend, a furry coworker with you,
Oh, wow,
or,
that'd be cool.
or a stay-at-home family member, another work-from-home colleague, feel free to post with them as well.
That'd be awesome.
Most of us are pet owners here, and we love pictures of pets.
Mhm. And so again, once you have that part cut away, we're just going to go ahead and continue with the edge taping.
Edge tape. Now I'm getting behind.
That's what happens when you're chatting.
I know. And I know I saw a question up there about if the boxes will be made available. Oops, over here. And I will definitely ask, because I know that I'm sure there's others out there that would like to join. I know we only made enough to ship out for today's demo, but I can definitely see about maybe getting some more made up.
That'd be cool.
If Ariel wouldn't mind. That is.
Now I'll just wait a minute on this slide while Casey gets caught up with her beautiful seam tape, by the way.
Wow.
Looks very good. I don't know if that's a ½ inch, but we'll take it.
It's a little bit wider than, because I'm using 2-inch
Oh,
tape.
I meant the overlap.
Oh, the overlap? Oh,
I did
I'm a little
see your tape was a little wider than typical, but hey, more coverage.
More coverage. Yeah, I cut down 2-inch tape to make this work. I was like, what do we have in the lab? Quick. It's gonna be a big baby, but that's okay.
All right, she's looking good. Next, we're just gonna, as I said before, just continue going around our blanket, doing our modifications. Luckily, the next two modifications are a lot shorter of a modification. We're just gonna cut our sides of our flanges from the caps, so that should go a little bit faster. And we'll still just do cut one side, apply the tape, then cut the other side, apply the tape.
Do all MLI have taped edges?
Typically, I would say 99.9% of MLI has taped edges, even if those taped edges are then covered in some type of overlay, be it beta cloth or whatever the overlay may be. There are also, was the question MLI or blankets?
All MLI.
All MLI. Okay, I was going to say we also have SLI, single layer insulation, and that's just a single layer of film cut so therefore you don't need tape to hold it together. I've also worked on projects though that were very sensitive to the possibility of tape failure at cold temperatures. And even those were stitched, even those were edge taped, but then they were also stitched on top of it just to act as a sort of mechanical fastener to keep what's holding the blanket together, which is a little insane to think about, but it happens. I don't know what that is.
I don't know what I did. Fine, we're here now.
But that's okay.
This will be a fun thing for everyone in the shop to look at.
I would love to see it.
Oh, my goodness.
Yep, and then once you have that cut, we'll go ahead and tape that side. And then continue on to the other side, cutting it and taping it.
AJ's trying to count the number of internal layers. Did I count correctly? 17 internals plus the 2 outers.
I believe we did, I can't remember if it was 12 layers or 14 layers, but we typically don't count the layers of netting. I'm not sure if maybe you're counting those by accident. I believe the blankets we sent out were 12 layers total, so it would be 10 internal 1/4 mil layers, and then the inner layer and the outer layer. I believe, but don't quote me on that.
And some of them may be different because I think some of them are scrap.
Right.
Right?
Mhm.
I don't know if they're
I tried to keep it consistent, but.
There's always a rogue
Mhm.
MLI on the sample shelf back there.
Of course. Because we're also green. We like to reduce, reuse, and recycle where we can. All right.
This guy, the bezel,
Yep. Let's go ahead and bevel our flange there.
if you're extra crediting.
Yeah, if you're extra crediting, if you're not, you can take a sip of your coffee, just try not to do it over the MLI. We don't want to spill.
That would not fly in the clean room.
No, it wouldn't fly and it wouldn't
We're
fly.
okay, we're working from home here. Speaking of the demo kit, yours hasn't arrived yet. Oh, Kim, I'm sorry.
Oh.
I know there were some shipping issues with FedEx, and it was hard. Some of the Colorado and West Coast addresses had some longer leads. Just cut this guy.
Mhm.
But it's definitely on its way. And if it gets rejected, I'll reach out to you in case the address was wrong or something.
And you said this was going to be posted somewhere that they could access?
Yeah, Parker just said they're hoping to have everything available next week on the TFAWS site.
Okay. That's fantastic. So once you have that cut, again, I know, sorry guys, it's getting a tiny bit repetitive, but you will also tape that side.
And hopefully be more even than I am doing right now. But that's okay. Oh my, don't look at it, AP.
All right. So here comes the trickiest of our modifications, and it is the modification for our harness location. So how we usually approach this is we usually start by just cutting one line so that we can kind of keep everything together. So we're going to go ahead and cut the part of our X, the leg of our X, if you will, that is kind of connected to our slit, and we're just going to cut one long line there through our X cut and everything. We're not going to cut our full X cut at one time. And typically we would punch the very end of our X cut, just so that way, as we talked about before, everything is relieved. We don't have any possible tearing of blankets, anything like that. But because we're in this work from home situation and, it'll get a little expensive to ship everyone a hammer and punches, so we decided against it. Oops, sorry guys. All right, and now we're gonna go ahead and edge tape that. So what I would suggest, just go ahead and move one side of the MLI out of the way and just focus on one side at a time. Once you're done with that one side, you can kind of, flip it and do the reverse. So you can use a little tab of tape to hold it out of your way, or perhaps put a little weight on it on the
In my case,
other
it's a
side.
friend.
In this case, yeah, she's I'm holding it out of the way for her.
Oh, no.
Oh, no.
Oh, my gosh.
How do you want me to hold this? There you go.
Thanks. Oh, BFF.
There you go.
Yeah, I can see totally how the stress relief sponge would help you here with you.
Definitely, definitely.
Wasn't my best work, but
That's
we're
okay.
here for it. Doing it on the fly. Be a demo.
Yeah, the stress relief punch is just like a nice point for you to kind of, so you can still maneuver everything and not worry about all the layers ripping. It's definitely an asset to the fabrication process.
Sweet.
All right, and then you can go ahead and do the same thing on the other leg.
This one should be better.
Yeah, once you have it a little taped, it's a little easier. Oh, I never thought about doing it that way, Casey.
I look it on the side.
Oh, wow. Casey has it kind of on the far side of her, so she kind of has to reach over the blanket to do it, but she's kind of taped and folded the flange of the MLI out of the way nicely. It's interesting to see different ways people do things. It is, because maybe I could add it to my repertoire.
True. I guess I will have to post a picture of myself with this.
Yeah,
After this,
yeah,
huh?
show this, yeah. Maybe you can get a hashtag started,
Yeah,
whatever the kids are doing these days. Awesome. So guys, we are so close to being done with these modifications.
Oh, can't wait.
The last thing we have to do is we have to finish this X cut. So we're gonna cut the other part of the diagonal, our little 1-inch area. But that leaves us with 4 areas that we have to tape, and they're all about a 1/2 inch wide. So you're really gonna wanna go ahead and cut your tape as close as you can to a 1/2 inch, kind of, it'll still be 1 inch wide, but a 1/2 inch width, so that you can just go ahead and apply your tape to these areas without having to worry about cutting off any little bits.
Bring it.
And with this, again, it gets definitely a little tricky without the stress relief punch.
Ooh, okay. She needs to fix her business out real quick. Gotta strategize here.
And as we are working from home, people, one way you can maybe do it, Casey, is kind of apply it to the outer layer of your blanket. Maybe you could flip your blanket over,
True.
kind of apply it and kind of just work it in your hands, since we're not as concerned right now with needing any type of forming requirements because of the flat blanket. And then, yeah, you could flip it over. But again, this is especially important. You don't want to tape your template to the blanket. Oh, I've done it on countless occasions. Or especially when we fabricate with stay mat and we have a 1 mil protective clear coating on the outside of it to kind of protect the stay mat coating. And then sometimes somebody gets a little too excited about fabrication and that 1 mil piece ends up getting taped into your blanket and you have to start over.
No.
No.
Okay. Oh, no, I ripped it.
No.
It happens to the best of us.
It happens, yeah.
I guess I will make a quick stress relief tape situation happen in here. Okay, well, this is very challenging, and it's a little frustrating to me at this moment, so maybe we move on from tiny X cuts.
That's fine. That's
Okay.
fine, guys.
Because I'm sure I'm not the only one struggling with a little bit.
No, it's okay. I talked to CC. They said we don't need 100% tape coverage. They said it's fine.
Okay, cool.
So we can move on.
I'm grateful that Contam is so helpful in this moment.
So here is a picture of how your blanket with the X cut will look once it's all done being modified. So what we're gonna do now to protect our X cut is to put stress relief tape on it. And basically those are pieces that are 1 inch width tape by about 1/3 of an inch wide. And we put them, as you can see in this photo, in little V's, where the V is at the very tip of the stress relief hole. So it kind of acts as another layer of protection against our modification.
The definite ripping that I allowed you.
Yes, well, it happens very easily. This is very delicate materials that we're working with. You know, it happens to even the most seasoned fabricators. Cool.
Oh, yours are kind of hard to see up there.
Yeah, the Kapton makes it a little more challenging.
Okay. You want to keep going
Yes.
while I take this out?
Yep, and as you can see from the photo, it'll be done on both the inner layer and the outer layer. And guys, can you believe it? You've modified your MLI.
Oh, wow.
I can't wait to see pictures of it, but I'm sure it looks great. The next thing we're going to do is go ahead and install our blanket. So, like Casey said before, it's very nice that our block here, we can just pick it up and move it around. So we're going to go ahead and use that to our advantage and just kind of go ahead and plop our backside right where it needs to go in accordance to our MLI. Cool. And if this was like a flight install, of course, we would use 966 to hold it down to the hardware, or some kind of adhesive, double stick adhesive. This is just going to be a temporary non-flight test installation. So we're just going to use tabs tapes wherever we install. So you're going to go ahead and pull down the cap. And as you can see in this photo, we'll just use tabbed pieces of tape to hold the cap down to the hardware. And if it makes it easier to install, go ahead and put a piece of tape, tabbed piece of tape on that slit that goes to the X-cut. Sometimes it's a little hard to install it because it becomes a little floppier in that region. And then we're going to go ahead and start wrapping our sides onto our blanket. We're starting to see how the sides of our blanket kind of meet the sides of our flanges. We can go ahead and put pieces of kind of temporary seam tape on there. We'll definitely use tabbed tape to tape our blanket to itself. Tape the flanges to the main body of the blanket, as you can see. Well, you can kind of see in this photo. Sorry, guys, but the Kapton on Kapton.
Kapton for days.
But we'll definitely use tabbed pieces of tape because we said it was going to be a test installation. And we don't have to seam it out completely. We can just do intermittent taping, and our pieces of tape, they could, again, be probably like 3 to 4 inches in length, just to feel comfortable with. So we're going to continue doing that all the way around and taping all of our seams in that fashion. And then there you go. Once you put your blanket down, you have a nice installed, slightly modified MLI.
Wow.
Wow.
Are you excited?
I'm very excited.
I'm pretty excited.
I could tell she started just through install. She wasn't even listening to me anymore.
I was
She was
just
just
going.
full steam ahead.
I was like, at this part I've seen before. I've seen this part of the show.
Yeah, so now you have a modified MLI.
Yeah. Okay, let me scroll back through really quick and see if there were any questions that we missed.
Okay.
Try not to poke myself with this. Yes, we'll find out about the more kits situation.
Mm-hmm.
Let's see what else.
Go home.
Can you review the trick to doing the tape in the punch hole? Oh, the thing that you told me where you stick it on the outside first.
Ah, okay. So, when we were doing the X-cut, Casey was struggling a little bit to get the tape into the X-cut just because, it's such a small little area. So what I had recommended to her was instead of having the inner layer facing her, I suggested she flip it over, have the outer layer facing her, and kind of place the piece of the piece of seam tape to place it halfway onto the cut like you would, and then that way you could kind of fold it back and turn everything over and feed that piece of tape through so that it could then cover it. It's a little, now that I'm saying it out loud, a little confusing to kind of describe. So I apologize, I don't have a more clear description of that, but hopefully that made some kind of sense. Basically, what I'm saying is you don't always have to stick to the rules of fabrication. If it's easier for you to kind of flip something over to work on it, there's always a time and a place for that.
Yeah. And we can, I know that there's some other questions, and we can definitely post maybe some pictures on Insta and Facebook for you guys. If you wanted to find more, we can definitely do that. Why would you put the Kapton side out and not the aluminum side out?
Oh, of the
blanket.
Oh, that's a very good thermal engineering question that I will direct back at Casey, our resident thermal engineer.
Yeah, so that really depends on whatever your requirements are, your thermal optical properties of the outer layer. So, you know, and Art can definitely maybe speak more to this, but there's a ton of coatings like VDA, Stay Met, Silver ITO that you can put on Teflon. So it really just depends on whatever that optical property is that you need of that outer layer. So sometimes that's Kapton, sometimes that's VDA. There's a lot of different films and coatings that you could use.
Right, like if you want something that has low admittance,
you want to go with VDA,
right?
Versus something high emittance, then you definitely want to go with a black Kapton.
Or I like to call Kapton out the poor man's black Kapton that you could use for testing.
You can use a thick gauge Kapton that'll give you kind of similar properties of black Kapton. Click. I think the next part is the Q&A.
Gotcha.
Cool. So special thanks to AP for helping me with this. We've been working on this for about 3 weeks, and I'm glad it happened, and I'm glad you guys are having fun. I have a couple questions for our panelists that I've prepared, but if the team, the group of you that are watching on the live stream have any additional questions for orbital composites, Aerothreads, or Dunmore, feel free to drop those in, and I will definitely ask them. So I kind of wanted to put my first question out to Dunmore. So Art, if you're still with us, I'd love to know what you think the most exciting mission is coming in the next 5 years that you've seen. And Art reads a lot of space news, so I'm hoping that he has a really cool answer.
Yeah, it's really tough to compete, I think, with the past couple months. So we had 3 different vehicles go to Mars, between Perseverance and the Ingenuity helicopter, and Hope out of the UAE and the Chinese rover. So Mars is really exciting, you know. So anything that we're looking at now arriving there, February timeframe for Perseverance. That's, you know, I remember when Curiosity landed and we were following along, and that whole 7 minutes of terror where, you know, they just really don't know whether it did it or didn't do it. And as each of those stages occurred, you know, back shell separation, you know, the landing rockets are engaged and touchdown. I mean, to me, that's pretty exciting. But if I have to look out further in time, you know, there's it's kind of like once you get one done, you're like, all right, well, now what do we do next? And, you know, as we're continuing to be able to participate in a lot of these other unique programs, you know, the Europa Clipper is coming up, and some of the other kind of interplanetary things, but top of the list, and Ariel will probably raise her hand, has to be James Webb. Once we can launch James Webb and we can start to get some of these pictures back from what will equate to the beginning of time as we know it, that's going to be it. We've waited a really long time. We've been providing materials into that program for over 10 years, and it's going to be really great when it finally goes.
Yeah, I know I'm sure a lot of people out there watching in the live stream right now, I'm sure they've had their hands on the hardware too, so it's definitely going to be exciting for everyone.
Definitely.
And Cole, if you're still on with us too, I wanted to kind of get your take, because I know that your robots are very much like changing the face of manufacturing. What do you think is the most exciting thing that your printers may be able to help manufacture on orbit?
Hello, thanks. Great presentation, by the way. So for on-orbit manufacturing, with small systems, I think what's really interesting to look at is the changing paradigm of launch. So as an example, if you're going to spend 75 or 80% of your spacecraft engineering horsepower on the first 12 minutes of launch for vibration and all these other problems, you're really only leaving about 25% engineering horsepower, man hours, available for the actual mission execution. So I think that the real cost here is that slows down the rate of change. And that's why part of the reason why we find it difficult to evolve away from legacy spacecraft bus systems and things like that. I think when you start to look at specific items that require tons of engineering for deployment, like antenna or reflectors, those are definitely a great place to see some changes, so that you end up space rating a printer that can produce a variety of antennas instead of space rating every single antenna that you make. That's a very different business model, a new idea. Beyond that, when you start to have a collection of manufacturing cells that are assembled in outer space, then it becomes possible to build kilometer scale objects or things that are just not possible to launch because of the pure violence of it. So, you know, we liken the launch window to having a fully decorated Christmas tree, put it in your car, go through a 12-minute car crash and expecting it to work on the other side. So when you change that idea, then it becomes possible to build very, very large structures. So some of the things that we would hope to see are that when you have space stations, you can start to even begin to think about centripetal gravity, which is not possible with the scale of ISS today, which is again limited by the launch volume. Yeah, so that's what we look at as the best benefits. Thanks.
Cool. Yeah, I know that we're always dealing with, you know, mass properties and vibe testing and all of those things, and I think everyone on the live stream would agree if we didn't have launch, I think it would make everyone's lives a little bit easier. But yeah, definitely interesting. And I got another one for Ariel. For customers that you've worked with on virtual fit checks and installs, what do you think has been the customer's biggest takeaway when it comes to MLI?
So I think typically what they're most shocked about is how important the template is to the overall fit and function of the MLI, and how really it's the one thing that is kind of used throughout all the stages. And so it's kind of like our key, our roadmap to our MLI, because we use it, we design to it, we use it on the hardware, we use it to modify the blanket, and then we'll even use it during install to kind of remember how things fold and form and all of our little notes on it. So I think that's probably the biggest takeaway, because people, they mostly just focus on the blanket itself.
And kind of on that note, what do you think is the biggest obstacle when you're working in new MLI design?
Wow, there is no question about that. It is the harnessing. The harnessing is always the last thing to kind of get decided, but it's the one thing that will always hold up MLI design, for sure. Even a small harness, even, oh, it's tiny, don't worry, it's it's a 24 gauge wire, a few of them together. Even that can definitely change the fit of a good fit of a blanket, for sure.
And kind of similarly, Cole, back to you, what do you think is the largest hurdle that you're seeing to make on-orbit manufacturing commonplace? And what do you think that the people listening, mind you, mostly thermal engineers, but maybe people that do some systems engineering too, what do you think they can do to maybe aid in on-orbit manufacturing?
Oh, an easy question. Yeah, I think one of the largest challenges right now is the lack of experience with additive manufacturing in general. And part of this is there's a very, very large design component that makes printing something non-deterministic in comparison to CNC machining. So you have a block of aluminum and you machine it down, you're pretty much always going to get the same thing. That's very, very untrue in the case of printed continuous fiber composites. So there's a very large knowledge gap required just to make the understanding of the process and properties well known. Potentially AI can solve this problem, but there's a design for manufacturing aspect. The other part of it is, you know, I guess just getting cycled in on new things. So there are some launch missions, right, from Made in Space and a few others right now that are attempting to do these things, but they're not looking at tightly integrated systems manufacturing. And so this is where we have maybe a very different opinion. Because what we want to do is not necessarily keep the manufacturing, mechanical engineering and the thermal engineering done by separate people in different teams. What we're trying to do is build a 3D printing system that can do lightning strike protection or give you surface conductivity, and then also give you an aerodynamic form, any dielectric layers you're going to need, and try to build in, if you want to think about it, a very strong computer that is, you know, sort of well sealed and very monolithic. So in order to get there, that's almost requires its own spacecraft and its own mission, where a large fraction of the aircraft or spacecraft can be produced with a multi-system additive way. So there's just a lot of, I guess, work to be done if you want to go big. But we think that certain discrete components, such as printable reflector antennas, kind of give you a good small piece of a very expensive problem to solve, and that's a baby step approach. The other problem is having a space-rated printer, but I think that's much smaller of an issue than the design for additive spacecraft.
Yeah, it's definitely a lot to think about. And I think too, like, you know, when you're talking about maybe some of the other people in the industry, I think that there's, like you're saying, I think that there's work being done, but I think I'd definitely like to see more. I think it's the future.
Sure. Definitely.
And this is a question from the audience, and I'm going to throw it out to Art because it was a very, very similar to the question that I had pre-written for this panel. What do you think is the next big thing for MLI and space installation?
Yeah, great question. And so much of what we do today still revolves around technology and materials and coatings that are 30 years old. You know, the PSA tapes are great examples. Those adhesives were created and qualified way back when, and you know, as we push the limits on cold and hot, they definitely become a challenge for us. So I think internally, some of the things that you'll see come out of us in the coming future, higher temperature materials, as we can partner with companies that actually manufacture those base products and then let us incorporate them into some of the other known structures, known tapes, types of materials. That's sort of one of the directions that we're trying to go in. And the other thing is just how do we take weight out of existing products? Every ounce is critical, and we're constantly challenged with creating full products that have the same optical properties as their heavier counterparts, but can manage the thermal, can manage the other tasks as good, just in a lighter form. So temperature and weight are the two things that I think are hopefully going to come out of Dunmore within the next 1 to 2 years.
Wow, I'm looking forward to those samples.
Me too.
Cool. And then Parker had a question related to the demo. So are you trying to avoid overlapping layers, or is overlap okay?
Overlapping layers.
Well, I guess there's a difference there between like a true MLI overlap versus like a cut, right?
Oh, are you talking maybe about the slit itself?
Maybe.
So generally, anywhere where you do have a seam in an MLI, you do want to have an overlap of some kind in order to not have as much leakage or reduced thermal properties, anything like that. There are going to be some areas like slits or modifications done after the fact that you really can't help just having that butt seam there. Sometimes I've been on projects, though, that at every seam they will want a patch blanket just to kind of accommodate for that. Or we try to design it so that a neighboring blanket in the subsystem will somehow have some sort of flange, or the geometry will work in such a way that that slit will be covered after the fact. Because a lot of the times the only purpose a slit forms in a blanket is to get around hardware that's already installed.
Yeah. So, but like generally, you'd want to overlap.
Generally, overlap is what you want to do, yeah.
Except in the case where you're overlapping 3 parts, and that's why we're cutting it away.
Exactly. There's still overlap there, but we don't need all that bulk.
Cool. Well, I think we're approaching the end. Oh, Parker says overlap on the fold, so I guess that's like the inside?
Fold.
Oh, the overlap of like one part of the blanket to the other.
Like over a corner?
Oh, over a corner, maybe.
Over a corner.
Over a corner is not ideal.
No.
Because you're going to crunch a little bit.
Right, exactly.
But that can be easily trimmed away.
Exactly.
Which would be okay. And if you need to do more mods, I think we gave you guys like 2 or 3 feet of tape, so.
Yeah,
lots of,
go to town.
Yeah, tape it up. I think everyone that works here has like a mutual love for the tape.
Love-hate relationship.
Love-hate.
Yeah, love-hate.
I think I used to use at least like 3 rolls of Scotch tape as a kid, so I'm grateful I'm in a tape industry. But I wanted to thank everyone for attending. I wanted to thank Art and Cole for joining us, and Ariel for being my sidekick today. And if you have any additional questions for us, you can, I think you can email them to TFAWS, or I put our contact information here, and I will distribute Cole's information. So if you registered on my Calendly, I will send out everyone's contact information through that. I will also be giving Dunmore and Orbital that same list. So they may be reaching out as well just to say hey and give you some contact info. But thank you again, Art and Cole. I'm glad you guys could make it. And I hope everyone has a great rest of the day.
Yeah, thanks, guys.
Thanks, everyone. Take care.
Awesome. Adios.
Bye.